Okay, hello everyone. Alright, so in this video, let's talk about logical operators in Java. Alright, so the way we've created our if statement is to check a particular thing. So let's go ahead and create a random or regular if statement here. And so we know the way if statements works, the way they work is this. If what's in the parentheses over here, if the Boolean expression in the parentheses over here results to true, then we know what's in this block is going to run, right? If what's in the Boolean expression is not true, then if we have an else, then what's in this else block is going to run. If we don't have an else, then the program skips over this if statement and continues with any code down below it, right? But if we have an else and the Boolean expression is not true, then that's what runs. If what's here is true, then what's in the if block runs. So we can, for example, create a variable. Let's go ahead and create an int variable. Let's call it number and initialize it to, let's say, 3. And over here we can check to see if number is greater than, let's say, 6, then we display a message. Let's have a system.out. What was I typing? Let's have a system.out.println. Typing gets bad sometimes. I don't know. It's bad in general. Then let's display a message, system.out.println. We can even use a value of what's stored in the variable number, right? So let's concatenate it with a string. Number is greater than 6. Sorry. All right, so if what's in the Boolean expression results to false, if number is not greater than 6, then we display a message saying that number is not greater than 6. All right, so let's test this out. We know number is 3. If it's greater than 6, we'll have a message saying number is greater than 6. If it's not greater than 6, we'll have a message saying that number is not greater than 6. Compile and run this, and it says 3 is not greater than 6, and that's true, right? So this is how we've used our if else structure, or our if statement, to kind of test things out. Now, what if you wanted to check or test multiple expressions? What if, for example, you wanted to ask the user for 2 numbers, but you wanted to test to see if those 2 numbers are all the same? You wanted to check to see if those 2 numbers are greater than a certain number, right? Logical operators allow us to take multiple expressions and then merge them to one, and all of them together results in either true or false. You kind of take multiple expressions. Logical operators allow us to merge them all into one. It becomes one expression, one Boolean expression, and it has to result to either true or false. So what if you ask the user to enter, let's say, 10 numbers, and you wanted to check for all the 10 numbers to see if all 10 numbers are greater than 10. The way we are writing our if statements right now is we are checking just one number over here. We are creating kind of one, we have one expression as our Boolean expression in the parentheses. But then logical operators allow us to merge multiple expressions into one, and then they have to result all that in one. All the expressions merge into one. That one expression has to result to either true or false. Okay, so logical expressions allow us to do things like checking to see if all 10 numbers given by the user is, let's say, or are greater than, let's say, a certain number, or less than a certain number, or are greater than or equal to a certain number, less than or equal to a certain number, equal to, right, double equals, to a certain number. We can check multiple expressions, okay, and logical operators help us merge them into one. So let's, this video is going to be an overview of all the logical expressions, but then there'll be separate videos to talk about the individual logical operators, right? I kept on saying logical expressions help us. We are talking about logical operators here, okay? Logical operators here. So this video is going to be an overview of all the logical operators, and in the next videos there'll be individual videos about each one of those logical operators, and talk more about them so we can have a better understanding of them. Okay, again, we're dealing with logical operators, right? All right, so let me use a comment over here to kind of list the 3 types of logical operators in Java, right? And so the first one is, now this is a comment, so it's not part of it. The first one is what's called AND, right? And it's used or it's denoted with 2 ampersand. If you want to write them in code, you use 2 ampersand. And what this actually means is the English word end. All right, we'll talk about that we'll talk more about it in a second. Actually, let me use multi-line comments for this. All right, multi-line comments for this. All right. My typing sometimes gets really rough. All right, so the first one is end, which means this 2 ampersand means end. The second logical operator. Now this two, okay, together, not spaced. Okay, it has to be together. This two now is the operator. It's just like a plus sign, but then two of them together becomes one. The next one is using two pipes. I call them pipes. It's on your keyboard somewhere. I call them two pipes. And this means the English word or, like or, right? And then the last one is the exclamation sign, and that means not. Okay, so how do you kind of use this in your Boolean expression or in expressions, right? To kind of create, you kind of merge multiple expressions into one Boolean expression. All right, so let's first of all have an overview of the end operator. Assuming we had two numbers, the user gave us, let's say, two numbers, right? So the first number has 3 stored in it, and the second number is also an int that is also 3. Oops, let's call this second number. I'm typing a bit rough here. So we have, let's call this first number. Two variables, first number. I don't know why I'm typing like this. All right, let me take a deep breath. So two int variables. First one is called first number. Stored. We are storing 3 in there. The second variable is also an int called second number. We are storing 3 in there. What if we wanted to create a Boolean expression that kind of checks to see if both expressions are equal to 3, or if both variables are equal to 3. So over here we're checking to see if, in this case, first number is greater than 6. We don't need that anymore, right? The way Boolean expressions work is this. Well, first of all, the way we'll check to see if first number is equal to 3 is we'll do something like this. If first number is equal to 3, if first number is double equal to, realize I'm using the double equal sign and not just the single equal sign. We know the single equal sign assigns what's on the right to what's on the left. If you're using a double equal sign, you are asking if what's on the right is equal to what's on the left. And so the way we will check to see if first number, if I missed the T here, is equal to 3 is this. And we are used to this because we've had several examples of testing like this, right? But what about the second number? How do we check to see if both numbers are equal to 3? Assuming we wanted to only display a message. Let's just change this message. I'll remove this for now. Assuming we wanted to display a customized message only if both numbers are equal to 3. The way you do that is by merging the end. Now we are talking about end, okay? You merge it this way, and you say that second number, and I'll explain this in a second, is equal to 3. Now we talked about the fact that this 2 ampersand signs meant end, or means end. So what this is saying is, if first number is equal to 3, and right, second number is equal to 3. If first number is equal to 3, and at the same time second number is equal to 3, then this Boolean expression results to true. The only time this Boolean expression results to true is if this first expression is true, and at the same time this second expression is true. Okay, anything else, this Boolean expression will result to false. So what I mean by that is, with the end operator, for the whole Boolean, when you connect two expressions with the end operator, for the whole Boolean expression to result to true, the first expression has to result to true, and the second expression also has to result to true. That's the only time two expressions connected with the end operator results to true. Even if at least one of them is false, then the whole expression here results to false. And we know that the way if statements work is this. If what's in the parentheses over here results to true, then what's in the if block is going to run. Else, then what's in the else block is going to run. With the AND operator, again, for the entire, if you connect two expressions, or if you connect two expressions or three expressions or four expressions with the AND operator, both or all the expressions have to be true for the entire expression to be true. Even if one of them is false, then the entire expression is false. Okay, so if first number is equal to 3, and if second number is equal to 3, then display a message. I'm sorry, this video is a bit rough. I think I'm speaking a bit fast and I'm kind of rushing through it for some reason. I don't know. Well, I'm relaxed too. Anyway, don't mind me. All right, so if first number is equal to 3, and at the same time second number is equal to 3, then display a message and say both numbers are the same, right? Else, then display a message saying that, copying that and saying both numbers are not the same. That's how the AND operator works. So when I compile this and I run, now it says both numbers are the same. As soon as I change one of them, again, if one of these expressions, it doesn't matter if it's this or that, if at least one of them, if both of them are false, then the whole expression is false. All it requires is that at least one of them has to be false for the entire thing to be false. The only time this expression is true is when both of them are true. If you use the AND operator for multiple expressions, you can have multiple expressions. You can have other expressions with it. You can have another AND here and have attach it with another expression here. The only time expressions that are joined by the AND operator results to true is when when all of them are true. So in this case, one of them is going to be false here because we've changed first number to 2. And at least if at least one of them is false, then the whole expression results to false. And we know that if with the if statements, the only time this block or this code in this block runs is when the Boolean expression here results to true. If it results to false, then what's in the else block runs. So when I compile this and I run, this time it says both numbers are not the same. All right, so don't worry too much. We'll talk more about the AND operator, specifically, and you'd have more idea about it. Now let's change this to the OR operator, and that's 2 pipes. Okay, it means the English word OR. So this means that if first number is equal to 3, or second number is equal to 3. And what this is saying is this: if at least one of these expressions is true, then that's all I care about. At least one of them has to be true. If at least one of them is true, then this whole expression is true. If both of them are true, that's even better. This entire expression is still true. But all it requires is that at least one of these expressions, is true. If this is true, then the whole expression is true. If this is true, then the entire Boolean expression is true. If both of them are true, then the entire Boolean expression is true. The only time this entire expression is false is when both of them are false. Okay, so it means the English word or, and it's true. When you say this or that, all you're saying is oh. So for example, if I go to a restaurant and I say that, give me let's say Coke or Fanta, that means I'm fine with any of them. If you give me Coke, I'm cool with it. If you give me Fanta, I'm fine with it. Right? Give me orange juice or apple juice. That means one of them is fine. That's the same idea we can apply here. If first number is equal to 3, that's one expression. Or second number is equal to 3. If at least one of these is true, then the entire Boolean expression is true. Okay? And if both of them are true, then the entire Boolean expression is true. The only time that this entire expression is false is when both of them are false. So if I go to the restaurant and I say, give me orange juice or apple juice, and they tell me they don't have any of them, then I can't drink anything. I leave the restaurant, right? The only time this becomes false is when both of them are false. But if at least one of them is true, then the entire expression is true. And if both of them are true, the entire expression is true. Okay? So that's when the or comes in play here. So let's see. First number is equal to 3. Second number is equal to 3. So let's see. If first number is equal to 3, we know first number is equal to 2. So that's false, right? And over here, we see we have an OR. So if first number is equal to 3, we know that's false. Or second number is equal to 3. We know second number is equal to 3. So this expression was also true. And with the OR logical operator, if at least one of them is true, then the entire Boolean expression is true. So we change this to at least one of the numbers, okay, is 3. Else we change this to there's no number, right? There's no number that's 3, right? Something like that. All right, so when I compile this and I run it, what should we expect? We know second number is equal to 3, and that's true over here. And at least one of if one of them is true, if at least one of them is true, then the entire expression is true. So we know that it's going to say that at least one of the numbers is 3. Compile and run, and it says at least one of the numbers is 3, and that's true because second number is 3. Although second number is 3 over here, although first number is 2. All right, so I know I'm talking a bit fast, but that's because I get excited when I talk about these things. And I talk fast sometimes, you know, in general. Again, when I'm excited about it. All right, so I was going to say that I talk fast in general. Yeah. Anyway, so let's change this. I was kind of thinking about what I just said. I talk fast in general, but you know, mainly when I get excited about stuff. Anyway, just ignore all that. Let's change this to, let's say, 5, and let's change this to 7, right? So compile it and check. If first number is equal to 3, well, we know first number is equal to 5, so this results to false, right? Or second number is equal to 3. We know second number is equal to 7, so this also results to false. And we know with the OR logical operator, if both expressions, or if all the expressions you're connecting with the OR are false, then the entire expression becomes false. And we know the way if statement work is, if what's in the Boolean expression is false, then we can't run what's here, right? That means that what's in the else part is what can run, okay? So because both of them are false, this whole entire expression results to false. Compile and then run, and it says that there's no number that's 3. And that's true, right? Because first number is 5, second number is 7. And we are checking to see if any of them is 3 because we're using the OR. And so, yeah, don't worry too much about the OR. Again, we'll have a specific video about the OR operator, and then we'll have more examples with that too. Let's talk about the last one, which is the exclamation sign, which means not. And that's the simplest of all of them. And if you apply the exclamation sign in front of, let's say, an operand, that's a unary operator. These are binary operators because it deals with 2 operands. And what I mean by that is, this is a binary operator. It deals with 2 expressions. You can think of them as expressions or operands, right? So that's one expression here, and that's one expression here. So one on its left, one on its right. If I have another OR here, there's one on its left, one on its right. But the unary operator, it works on only one operand or one expression. And so the way that works is this: it just negates what's stored in a Boolean variable. So if I have let's create a Boolean variable over here. I'm going to delete a few things. Boolean variable, and then let's call it found, and let's set found to be equal to false, right? Let's not even have an if statement here. Let's just use a system.out.println to display what's stored in false. So system.out.println. Let's display what's stored in found. Now we know false is stored in found, right? So let's compile it and then run, and then it says false. Now, if you apply the exclamation sign in front of the found, you are basically, well, first of all, it means not, right? You're basically negating what's stored in there. So over here, what you're saying is print out the opposite of found. Okay? This means not. At the same time, when you read it, it means not found. Right? So if print out, we know found stores the value false. So if it's not false, then what is it? That means it's true. So when I compile it and I run it, it says true. If I remove the exclamation sign, found is equal to false, it stays at false. The not logical operator basically negates basically something, an expression or what's stored in a variable, like in a Boolean variable. So false is stored here. This means not, so not found, okay, or the opposite of what's stored in a variable here. What's stored in a Boolean variable. So not found, compile and run, it says true. If at the same time, if I change, let's remove the exclamation sign. If I change what's found in to true, initially when I compile and I print, and I run it, it says true. But when I put the exclamation sign in front of it, not true, okay, not true. We know found contains the variable, or the value true. I can't keep on mixing words. We know found contains true. So not true means it's false, right? Compile and then run, and it says false. So I'm sure you are probably wondering, why are we going to use this? Maybe it made sense when we were talking about the and or the or, but then maybe not. Maybe not the nots. Like maybe you get it, but then how are we going to use it in programs? We'll see examples of it moving forward. In the next videos, I'll talk individually about these operators, and or not, and we're having some example programs so we can kind of see the essence of it. All right, but I hope this at least gave you an understanding of it. Basically, it was an overview, but I hope it gave you an understanding of it. But we'll talk more about it in the future, okay, in the future videos. All right, I think I talked a lot in this video. I talk a lot, that's the thing. I always do talk a lot. Just want to make sure that everything is clear, and that's why I keep on repeating stuff. And as long as it's helpful, I'm glad. If it's something you already know and you feel like you've already understood and I'm still talking about it, feel free to skip through it or fast forward it or something like that. But if it's helping you and the pace is good for you, then I'm glad. All right. So if you have any questions, please comment down below and I'll do everything to respond to them. Thank you very much for watching. Take care of yourselves as always, and I'll see you next time in the next video. All right then. Bye-bye.